Hey, Math 6, this is Mrs. Spence, and this week we are looking at different types of graphs. So, this is a statistical concept, and we are specifically going to be looking at choosing the best graph for the data that we have so that we can have the best visual representation of the information that we are trying to get across. So, let's take a look. Okay, so we're going to take a look at three different types of graphs. You've learned in past years how to create bar graphs and line plots. This year, our focus is on creating circle graphs. And so we are going to look at that new circle graph compared to those other two graphs that you've already had practice with creating and deciding when are we going to use these different types of graphs depending on the data that we're looking at. All right, so you have these in your notes, but I just wanted to do a quick summary of when we're going to use a bar graph. Okay, so bar graphs are best used when you're looking at categories of information and you're having a frequency count of those categories. So we're going to look at I'm going to just give a quick note that it's a frequency count of categories. So you can see with your example here that we are looking at favorite sports amongst these fifth graders, and we have categories around the bottom, and up the top would be the number of votes that each of those sports got. So that would be your frequency count, and then the categories along the bottom. So this is used when you're comparing more than two or more different categories, and you want to see who has the highest bar here for the best number of votes or things like that, depending on what you're surveying. So this again is used for frequency counts of categories, and the visual is helpful to see when something has the most or the least number in each category. All right, so that is what it helps you see if you want to add that note to you as well. You can see the most and least amount of, you can say, votes in this case. Okay. All right. In a line plot, that is where you get to see a little bit more detail, and you can see numbers along the bottom axis there. It's still a frequency count. All three of these graphs that we are comparing are all frequency counts, but they all show a little bit different information, okay? So on the first one, you see the most and least votes in categories. This one, you're actually going to see those measures of center that we've been looking at, okay, where you can see the mean, the median, the mode, the outliers. You're going to be able to see where information or data is clustered. But it's still talking about frequency counts of things, but instead of categories, it's talking about frequency counts of specific numbers. You can have specific categories listed on the bottom. If you were talking about number of votes, again, for favorite sport, you could put, instead of numbers there, you could put categories. But you frequently will see line plots more dealing with ranges of numbers. So we're going to add that little note that this is still used for frequency counts, but it's usually frequency counts of numbers, test scores, actual quantitative pieces of data. But it will show, you see, specific scores, or number data. It also helps you see the mean, the median, and the mode, and any outliers very easily. It also shows you the range because the bottom number there is going to, or the line number here is going to show you the range. So in this one, the number of minutes studied, the range of numbers is from 30 to 70. All right. Pull this over here. Still a frequency again, but it's going to give you more specifics on those measures of center. And then finally, the circle graph. We all very much know that circle graphs show percentages. Okay, it's still a frequency count, but it's usually of categories. So back to categories, and you can see this helps you see the percentages or the parts of a whole. So the parts of this whole group. Um, It's really not going to be one that you're going to want to use if you have more than 7 categories, though, because then your pie chart or your circle graph slivers are going to get, or sectors are going to turn into very tiny little slivers. So keep that in mind. I did kind of underline that here in your notes. So it's good for showing smaller number of categories. But if we want to see parts of the whole, or we want to see them in that percentage format, then a circle graph is what we use. Now, I wanted to actually show these 3 graphs with one set of data. Okay, and it's in a set of data that is commonly understood among students, and that's test scores. So, test scores can be shown in a bar graph, it can be shown in a line plot, and it can also be shown in a circle graph. And then we're going to talk about which one do we think is the best graph for this data. All right, so specifically, we're looking at test scores for 8th graders. There were 8 students in this, maybe let's say an elective class, and we have the following grades. So with the bar graph, remember that bar graphs cannot show specific numbers, they show categories. So we need to first make these become a category. So what I think of is maybe breaking them into A's, B's, C's, D's, and F's. So if I'm looking at this, I have 3 pieces of data that were A's. I have 3 that were B's. And I have 1 that was a C. And then I have 1 that was an F. All right, so now I've taken numbers and I've broken them into categories, A, B, C, and F, because we don't have any D's. All right, and then what we would do to set up our line or bar graph, we would have number of students along the y-axis, and we would have the categories along the bottom. So we'd have our A, B, C. I'm going to go ahead and put the D in there because it's also helpful to see when a column is blank, because it shows us we have no D's, not because some might think, well, maybe they just forgot to put it in there, but this will show we have no D's. All right, so we have 3. So I'm going to run up here. 1, 2 students, 3 students is our max on this example, but we'll go ahead and go to 4. All right, so we had 3 students in the A group. We had 3 students also in the B group. We had 1 student for the C's, no students for the D's, and 1 student for the F's. All right, so this would be an example of a bar graph that was created from our test grade data. Now, let's look at the line plot. So remember, line plot is going to go from your lowest grade to your highest grade to show the range. So our lowest is 50, our highest is 100. I'm going to go ahead, for the sake of time here, put them in count by 5s here. So we'll have 55 and, or excuse me, 55 and 60, 65, 70, 75, 80, 85, 90, 95, 100. All right, and then remember that X represents 1 student. And every time we plot an X for the number, it's going to represent that's how many students received these test grades. So we would want to label our axes, test grades. You'd want to give it a title. We have our title up here, so I'm not going to rewrite it here. But we would say, all right, we had a 150, we had a 170, we had 180, we had an 85. Oh, we had a second 85, and we had a 90, a 95, and a 100. So this shows our data with the line plot. And with this, you can see the benefit that we talked about where you can see the mean, the median, mode, and outliers. We see that we have an outlier here. This is way separated from the cluster over here, and this one's kind of separating from the cluster, but you can see that the majority of the test grades were in here. So our mean, our median, here's our mode. We have 2 here where everything else is just 1. If we found our median, we'd count in. So we have 1 at the 50 and 1 at the 100. We'd count in at 70 and 95. We'd count in at 90 and 80, in at 95 and 95. So actually our median is right here in between the two 95s. So our median would be 95. Our mode is 95. And then if we average these, you would see definitely that 50 is going to pull it down from 95. So the outlier here makes the mean not the best representation of this data, but you can see all of that very visually here with a line plot. So this gets very detailed information for these numbers. All right, and then if we were to look at the circle graph here, again, it needs to be in categories for this. Although test grades are percentages themselves, remember we're talking about part of the whole graph. So the percentage is how many parts they got right out of the total number of test questions, but that's not what our graph is showing. Our graph is showing the parts of the student group that we're testing, so the 8th graders here, that got an A or that got a B, so this is, we need to again go back to our category data up there with A's, B's, C's, D's, and F's. We had one F, no D's, 1 C, 3 B's, and 3 A's. And then we can take that information and say that we had, that's a wonky one there, sorry. How many students did we have in that class? 8. So there were 3 out of the 8 students that got an A. This is your part over your whole. And if we found the percentage of that, remember we would divide 3 divided by 8. And you're going to get a decimal here, but it's 37.5%, which would be the same for the B's because it's the same fraction. The C's, we had 1 out of the total 8 students got a C. And that, when you do the division, turns out to 12.5%. 0 out of 8, that doesn't even need to be represented on our circle graph. And then our 1 again here, 1 out of 8, so 12.5%. Remember that when you total these all up, they should equal the total 100% of your circle. And if we wanted to be real technical, we could use our formula to find out the exact degree of our sectors, but we're just going to estimate it here. All right. The other thing you could do is you could break your circle into 8ths and then color in 3 of them and 1 of them. So there's 4, 7, 8. All right. So now we have 8 sectors. And if I were to color them in, I would want to use different colors and label them. So we'll have 3 of them got A's. I'm going to be pretty lazy in this. 3 of them get B's. We had 1 student out of the 8 to get a C. And then we had 1 student get an F. Okay. And then you could list out your percentages in there as well. All right. So that is showing the same data 3 different ways. So now let's kind of compare which type of graph do you think is the best representation of this data? All right, and this can be a matter of preference. What I can say is that the bar graph here does not really show that much. You can see that you have 2 that look alike here and that they have the same number. You have none in the D category. So visually, you can see that there's a missing letter grade there. So you can kind of get some information out of it. Um, Same with this. Teachers may use the circle graph here because they want to see the percentage of their students out of all of the students that got A's, B's, C's, and F's. And so if I were to look at this as a teacher, I would say, yeah, that's a nice spread here. So if C is average, the majority of the students got an average or better, and only a little sliver got a failing grade. And then the last one, the line plot, shows very detailed, specific information. It shows you that we have an outlier. It shows you where the mean, the mode, the median would all be clustered. So for me, I might be voting for the line plot being the best use of graph in this case. But again, it could be up to personal preference here. Um, all 3 of these would be great examples of graphs for this data. But with the first one and the second one, we had to transform them into categories. So there might be that argument that with the line plot, you didn't have to change anything and you're truly showing the data that they give you, which were numbers. And only the line plot can really do that in this case. So, all right, guys, I hope that that helped you understand when to use different types of graphs. But please do remember that each graph has its own purpose. And we're going to be learning more throughout your math journey throughout the years of different graphs, and you'll be getting to create other graphs as well, and each of them will have their own purpose as well.